Hi everyone, this video will cover equations of lines. And remember that equations of lines written in slope-intercept form is y equals mx plus b. That letter m, the number that's in front of x, is your slope, and the y-intercept is behind x. You have plus b here, but sometimes you might have a minus b, meaning that your slope is negative. And that y-intercept as an ordered pair would be 0b, where 0 is always the x-coordinate of the y-intercept. Now in this example, we're going to graph the equation y equals 1/2 x minus 3. Now we're going to start with graphing so we could remember how that relationship between the graphs and the equations occur. First of all, this equation is written in slope-intercept form where we have y equals mx plus b. So thinking of our slope-intercept form, we know that the m is in front of x. This is our mx. So our slope is going to be 1/4. Our y-intercept is going to be -3. That's behind x. We'll use those two pieces of information to graph the line. First, you're going to plot the y-intercept. Our y-intercept is -3. So we're going to go over here to the y-axis. This is your y-axis that runs vertically up and down. This is your x-axis that runs left to right. So on the y-axis, we'll go down 1, 2, 3, -3, and we're going to plot the point. Step 2, we're going to use the slope to find a second point. Our slope is our slope is 1/4. Because it's a +1 in the numerator, we'll move up 1 space, +4, and the denominator will move right 4 spaces. Starting at -3, you start at your y-intercept, we'll go up 1, right 4, and plot the second point. So starting here at -3, 1, 2, or 1 up, so 1 up, and then 1, 2, 3, 4 to the right, plot that point. And lastly, you'll connect those 2 points to create the graph of the line. Now, if you have an equation that's not written in slope-intercept form, like this example, we have 2x plus 3y equals 12, you have to first solve for y to get the equation in slope-intercept form. So to do that, we're going to subtract 2x from both sides of the original equation. So minus 2x on the left, minus 2x on the right side. The 2x's will cancel on the left, leaving this 3y equals, on the right side, remember we subtracted 2x, we have minus 2x plus 12. Lastly, we're going to divide both sides of the equation by 3. So everything on the right side and everything on the left side by 3. And that 3's cancel, leaving y equals -2/3 x, and then 12 divided by 3 gives us 4. Now we have our slope, our m, and our b, our y-intercept. We'll use the slope and the y-intercept to graph the line. Step 1, we're going to plot the y-intercept. So on the y-axis, we're going to go to 4. Remember, your y-axis runs vertically up and down. Your x-axis runs horizontally left to right. So we'll go to 4 on the y-axis. 1, 2, 3, 4, plot the point. And then from there, we're going to use our slope to get the second point. Our slope is -2/3. We're applying that negative to the numerator. So that's -2, meaning down 2 spaces. And in the denominator 3, we're going to move to the right 3 spaces. So starting at 4, we'll go down 1, 2, and then right 1, 2, 3, plot the points. And then that last step, we're going to connect these 2 points to create the graph of the line. Now here we are. We're going to use our slope-intercept form to write the equation of the line. So here our slope-intercept form of the equation, remember, is y equals mx plus b. In our directions, we're given the y-intercept as -3, so our b is -3. And our slope, our m right here, is 1/4. So we'll use 1/4 as our slope, substitute it into the equation, and we'll use -3 as our y-intercept. To write the equation will be y equals 1/4 x minus 3, after we substitute 1/4 for m and -3 for b. Now, if we're asked to graph this line, let's go back one step. If we're asked to graph that line, we would use our y-intercept first to plot the first point. So on our y-axis, we'll go down to -3, 1, 2, 3, plot the point. And we'll use this slope. Our slope is 1/4, +1 and +4. So that means we're going to move up 1 space and to the right 4 spaces. Starting at the y-intercept of -3, we're going to go up 1, right 1, 2, 3, 4, plot that second point, and then we'll connect the 2 points to create the graph of the line. All right, now there's another form of an equation called the point slope form. The point slope form of the equation of a line is y minus y sub 1 equals m times x minus x sub 1. So we remember m from the slope-intercept form. And just like in the slope-intercept form, the variable m stands for the slope. So whichever number we have that's in front of our x is going to be our slope. The ordered pair, the reason why it's called the point slope form, because you have a point and the slope. The point for that ordered pair will be labeled as x sub 1, y sub 1. So when you're given a point, let's say we were given the point 5, 3, we would substitute that x coordinate as x sub 1 into the formula, and the y coordinate as y sub 1 into the point slope formula. And we're going to look at an example. All right, so we're finding the equation of the line when our slope, our m, is -3, and our point, our x sub 1, y sub 1, is 1, -5. And we're going to write the equation in slope-intercept form, but we're using the point slope form. So we're starting with point slope form, y minus y sub 1 equals m times x minus x sub 1. And remember, in our formula where m is, we're substituting the value -3. We're given the slope of -3. We're also giving x sub 1. X sub 1 is 1. And then y sub 1 is -5. So we're going to substitute those 3 values into our equation, the point slope form. Now, when we do that, we have y, so y remains the same, minus y sub 1. Our y sub 1 is -5. So we got y minus our y sub 1, and our y sub 1 is -5. We'll put -5 in parentheses, equals m times x minus our x sub 1, which is 1, close the parentheses. So we have y minus -5. Now a minus and a minus side by side, remember this becomes addition. So this becomes y plus 5. And on the right side of the equal sign, you have to distribute this -3. So that's -3 times x and -3 times -1. That gives us y plus 5 equals -3x plus 3. Now, remember we were writing this final equation in slope-intercept form, so we need to get y by itself on the left side of the equal sign. Therefore, we need to subtract 5 from both sides of the equation. And when we do that, we'll get slope-intercept form. Y equals -3x minus 2. That's 3 minus 5 gives us -2. And we're done. In the next example, we're going to find the equation of the line when we're given a slope of -4. So m equals -4. And it contains the point -2, 5. So we're going to use our slope. Our m is -4 and the point -2, 5. To find the y-intercept, this is another method we could use to find the y-intercept. First, we would start with the slope-intercept form of the equation, and we're going to substitute the numbers that are given to us. Where m is our slope, we will substitute -4. Where x is, we would substitute -2. And where y is, we're going to substitute 5. So we'll have 5 equals -4 times -2 plus b. And -4 times -2 gives us +8. We carry down the 5, the equal sign, and the b. Now we'll just solve this equation for b. So we're going to subtract 8 from both sides of the equation, and we'll get b equals -3. Now that we have our y-intercept, and we already had the slope from before, we'll use that slope and y-intercept to write the equation. So using our slope-intercept form of the equation again, we're substituting -3 for b and -4 for m. Our equation would be y equals -4x minus 3. And we're done. All right, now we're going to use the point slope form to write the equation of the line. We're given 2 points, 4, 0, and -4, -5. Now, in the end, we're asked to write this equation using function notation. So we have a reminder here of how to convert our standard slope-intercept form of an equation to functional notation. The only thing that's different is our y-coordinates. So on the left side of the equal sign, instead of having y, you're using f of x. The right side of the equation will stay the same. So we're going to use these 2 points that we were given to find the slope. Now, when we're using these 2 points, we want to go ahead and label our x and y coordinates. So our first point would be x sub 1, y sub 1, and our second point would be x sub 2, y sub 2. We're going to use those 2 points to find the slope. The formula to find the slope when you have 2 points, remember, is y sub 2 minus y sub 1. So you take the difference in the y coordinates divided by the difference in the x coordinates. X sub 2 minus x sub 1. So in the numerator, y sub 2 is -5 minus y sub 1, which is 0. So we have -5 minus 0. And in the denominator, x sub 2 minus x sub 1, our x sub 2 is -4 minus x sub 1, which is 4. So we're simplifying here, -5 minus 0 gives us -5 in the numerator. And -4 minus 4 gives us -8 in the denominator. A negative number divided by a negative number gives us positive. So this becomes 5/8, positive 5/8. That's our slope. So now that we found our slope, we'll just use one of the original points, either the 4, 0 or the -4, -5. Either one of these points you could use. We're going to go ahead and use the first point, and we're going to find the y-intercept. So we're using the slope-intercept form of the equation. We're substituting 5/8 for our slope. We're going to use this ordered pair, 4 everywhere we see x, and 0 for the y coordinate. That gives us 0 equals 5/8 times 4 plus b. So we're distributing here 5/8 times 4 gives us 20/8. And then we're going to subtract 20/8 from both sides of the equation. Now when we do that, b is negative 20/8. That's our y-intercept. So we'll use the slope 5/8, the y-intercept negative 20/8 to write the equation. Remember, the slope-intercept form is y equals mx plus b. We're substituting 5/8 for m and negative 20/8 for b. However, for this particular problem, we were asked to use function notation. So instead of the y on the left side, we would have f of x. The final functional notation would be f of x equals 5/8 times x minus 20/8. All right. Now in this problem, we're asked to find an equation of the line that's already graphed for us. We see this blue line down here in the bottom right-hand corner, and we're going to write the equation in standard form. First, we're going to find the y-intercept, the b. Where does this line cross the y-axis? And we see that the line crosses somewhere between 4 and 5. It's not quite in the middle, so it's not at 4.5, a little bit below that. We estimated it to be about 4.25. So for B, our y-intercept, we're going to substitute 4.25. Now, we will use 2 points to find the slope. Pick any 2 points on the graph. All right, I'm going to choose this point right here because it crosses in between two lines. I see I'm at -4, 3. And then I'm going to choose another point that's also between two lines right here at -1, 4. And then I'm going to measure how far I move up and how far I move to the right to get from this first point I'm going to label as number 1 to the second point. So to get from point 1 to point 2, I have to move up 1 space and right. So up 1 space and right 1, 2, 3. So my slope, because I moved up 1, right 3, is going to be 1/3. This is our m. Now we have our slope and our y-intercept that we will substitute into the slope-intercept form of the equation. So we have y equals 1/3 x plus 4.25. However, our direction said write the equation in standard form. Standard form is a third form, and ax plus by equals c is the standard form of an equation. Standard form. In standard form, you have both x and y on the left sides of the equal sign. In slope-intercept form, you see we only have the y that's on the left side of the equal sign. So to convert this equation from slope-intercept form to standard form, all we do is move this x term, this 1/3 x, to the left side of the equal sign. We subtract 1/3 x from both sides of the equation. When we do that, the 1/3 x cancels on the right side of the equal sign, leaving 4.25. On the left side, we now have -1/3 x, it should be a minus here, plus the y, and it equals 4.25. That's standard form. Now we're asked in part B to find the value of this function when x is -1. So f of -1. We'll take the function notation of the equation. So f of x instead of y equals, remember it equaled 1/3 x plus 4.25. So in order for us to find the value of this function, when x is -1, we're going to substitute -1 everywhere we see x. So this becomes f of negative 1 equals 1/3 times negative 1, so that's 1/3 x, plus 4.25. And we simplify, we'll get 1/3 x times negative 1. That becomes that 1/3, or we had the positive 1/3 times negative 1, so that became negative 1/3 plus the 4.25. So f of negative 1, when we simplify and add these two terms together, and by the way, this fraction, you can convert it to a decimal by simply dividing 1 by 3. Do 1 divided by 3 in your calculators, you'll get 0.3 repeating. And then add 4.25 to it. It was a negative number, so you'll get negative 0.3 repeating. And then add 4.25, you should get 3.92. And that's the value of the function when x is negative 1. Now part C says find x, this time when f of x is equal to 5. Now think about this f of x term. When we have f of x, remember f of x is the same thing as y. So essentially that's what we're doing in the standard form of the equation, is we're substituting 5 in place of y or f of x. So instead of f of x equals 1/3 x plus 4.25, we have 5. We're substituting 5 for f of x equals 1/3 x plus 4.25. Now we'll solve this equation by subtracting the 4.25 from both sides first. And when we do that, we'll get 5 minus 4.25 gives us 0.75 on the left equals 1/3 x. And now we'll take the reciprocal of this 1/3. Remember, we flip the fraction, and that becomes 3/1. 3/1 is the same thing as 1, and we multiply both sides of the equation by that reciprocal 3. And when we do that, we'll get 2.25. That's the value of x when f of x is 5. All right, now we're going to write equations of the vertical. Remember, vertical means up and down, and horizontal lines for this example, which is 2, 3. We have this ordered pair of 2, 3. So our x coordinate is 2, our y coordinate is 3. Let's plot this point. So when we're on our x-axis, we're going to move over 1, 2, and then on our y-axis, we'll go up 1, 2, 3. Here's that ordered pair of 2, 3. Now we want to know what are the horizontal, so that means left to right, and the vertical lines, that means up and down. We want to know the two lines vertically and horizontally that cut through this point. Now we can see this horizontal line that cuts through the point, cuts through that point right here at 3. On the y-axis, the equation of that horizontal line would be y equals 3. Now the vertical line that runs up and down, you see how this line cuts through the x-axis at 2. So the equation of that vertical line is going to be x equals 2. So there you have your vertical and horizontal lines that go through 2, 3. Now we're asked to write equations of parallel and perpendicular lines. So find the equation of the line that contains this point. So it has 4, 4, and it's parallel to this line that has the equation 2x plus 3y equals negative 6. First, we need to use this equation to find the slope. To do that, we're going to solve for y. We got to get y by itself, so we're going to start by subtracting 2x from both sides of the equation. And when we do that, we'll get 3y equals negative 2x minus 6. Then we're going to divide both sides of the equation by 3. So we'll get y equals negative 2/3 x. And then negative 6 divided by 3 gives us negative 2. So our slope is negative 2/3. Now, what we know is that parallel lines have equal slopes. Therefore, if the slope of the equation of this line is negative 2/3, then the slope of the line that's parallel to it is also going to be 2/3. We have our slope. We've used that equation to find our slope. Now we'll move on to step 2. We're going to substitute that ordered pair, that point that we were given, 4, 4, into our slope-intercept form of an equation. So we're substituting 4 for x, 4 for y, and negative 2/3 where m is. So we'll get 4 equals negative 2/3 times 4 plus b. We're simplifying here. Negative 2/3 times 4 gives us negative 8/3. We're going to add that negative 8/3 or add 8/3 to both sides of the equation. And again, you can change this decimal to a fraction by dividing 8 by 3 and then add 4 to it. You'll get 20/3. So we have b and we have m, and now we can write the equation of the line. So we're substituting m and b. Our equation would be y equals negative 2/3 x plus 20/3. For this example, we're writing the equation of the line that's perpendicular. So it's perpendicular to that same equation that we had from before and using that same point, 4, 4. Now, looking at our equation, we're first going to solve for y, which we already did. Remember, we subtracted 2x from both sides of the equation. And then we divided both sides of the equation by 3. So we got our slope as negative 2/3. However, what we know about the slopes of perpendicular lines is that they're opposite reciprocals of each other, meaning the signs are opposite. So since this slope of the given equation was negative, then our slope is going to be positive. Now the reciprocal, remember we get the reciprocal by flipping this fraction. So that 2/3, we're going to move the numerator to the denominator and the denominator to the numerator. And that's how we get 3/2. Now that we have our slope, we're going to substitute that ordered pair, the point that we're given, x and y, and the slope into the slope-intercept form of the equation. We'll get 4 equals 3/2 times 4 plus b. And we're going to multiply 3/2 times 4. We'll get 12/2. 12/2 actually simplify. 12 divided by 2 gives us 6. So we're going to subtract that 6 from both sides. And we'll get b equals negative 2. Now we have our y-intercept and that slope. We can write the equation of the line. So we're substituting 3/2 for m and negative 2 for b. We'll get y equals 3/2 x minus 2. And that's the last equation for these notes.